Thanks everybody for joining this session. It's about DDataflow, end-to-end test for machine learning pipelines we've developed in GetYourGuide. I'm doing this talk together with Theo, my colleague. He's having some technical difficulties, but he will join the session as we proceed. But for the sake of time, I'll get started. So, yeah, first point is a little bit about who we are. So my name is Jan. I'm a data science manager in GetYourGuide. And GetYourGuide, for those who don't know, is an online marketplace for travel experiences. I work there together with Theo, which is my French coworker. He's also a data science manager in GetYourGuide. We have a lot of data in GetYourGuide and tons of machine learning running in production. And that means also that there is a lot of ML pipelines to be optimized that we are working on daily. So and that was the origin basically of this project of DDataflow. With that said, I will introduce the agenda for today. So let's start with understanding the challenges around testing machine learning pipelines. Then what we discovered to be a need for a tool that kind of help us to do better end-to-end tests of machine learning pipelines, how we implemented this tool, and then we want to conclude with some learnings from this process. Let's get started. So what are challenges around testing ML pipelines? So first of all, let's go back to principles and think what is testing about, right? So testing is about changing our systems in a way that we, with confidence, we getting feedback for the changes we are making in the systems. So there is one aspect of it is the feedback loop. So I make a change in my system. How fast can I see that this change is actually doing what I wanted, or there is a problem with it? This is one kind of very central point in software productivity. So if you have a fast feedback loop, you can iterate very quickly, try out different things, and move on fast. But ML pipelines bring unique challenges to this kind of testing. The first, let's take a look on what those challenges are. So first of all, there is a lot of complexity. ML pipelines have a lot of data sources to be joined. Errors don't need necessarily to be about schema problems. They can be also just distribution problems, data distributions, and those are very hard to detect in the code. Also the scale, right? There is tons of data, sometimes terabytes of data to be processed. And so to run that fast and get a fast feedback loop is rather a challenge. Finally, these systems are operated not only with engineers, it's a diverse team that's operating ML pipelines, data scientists, people with academic background, and they have very different skill sets from kind of, so we have to accommodate for all these skill sets, and that's something we want to keep and preserve. So now that we understand a little bit more what are the unique challenges of ML pipelines, let's look into unit tests for ML pipelines. Is that a viable option or not?
Okay.
Yes.
Can you hear me? Yes. So can you go to the next slide, please?
Sure. Sorry.
Yes. Okay. Sorry for the start. I had some, of course, Chrome wanted to restart itself. I apologize. So can we test? Can we unit test ML pipeline? We tried to replicate this mindset of a classical software by adding test to ML pipeline. In particular, we try to push to have unit test coverage on the critical parts. But building and maintaining these drag us the velocity of the team for three specific reasons. First one, we learned that a lot of DS code is actually not really unit testable. How do you want to unit test that a model was trained, or how do you want to unit test that the that the code to create the training data has the right join condition. To make it clear, there are some specific code or function that can be easily tested, but a big chunk of the DS code, data science code, was not easily testable, unit testable. Second one, we saw that ML, machine learning, is in constant research, is really research oriented, which means a lot of experimentation, and a lot of the experimentation needs to some major refactor of the code in very different and unpredictable way. So every time we had to refactor the code and also refactor a lot of the unit tests that go with. Finally, we also saw that even if we had a good unit test coverage, we still saw error popping up more on the integration level. To explain a bit more, ML pipeline we usually break down in multiple steps. And we end up changing one step and everything works on the unit test level. However, it ended up breaking another step down the line that we did not foresee. So for this reason, we struggle to unit test the pipeline. Can you go to the next slide, please? And now we also struggle a bit with the test and the production data. Indeed, the ML pipeline combine code with data, and in order to fully test the pipeline, you also need to create realistic dummy data, which end up being very time-consuming. Code Copilot now can help a lot with that, but it's still cumbersome. In practice, what we saw is that most of the line of code end up being hard-coded fake data or code to generate realistic fake data. This creating and maintaining this is cumbersome. And what we still see is that there is no link between this fake data and the production data. And this comes as a cost sometimes, or having bugs that only appeared in production. So we struggle for some time to implement these tests and making them lightweight to maintain and get an effective coverage while getting limited benefits from this testing strategy. However, we saw that in the company level, their end-to-end tests, when done right, can be a great success. And so we wonder if we could improve on this.
Cool. And yeah, let's now zoom into our process of looking into end-to-end tests and that ended up leading us to create the DDataflow. So we started basically with trying this idea. Let's have an end-to-end ML pipeline in a project, and we basically get all the steps, put in a single script, tie that to the CI, and we saw very fast that was great for validation. Like we get like feedback back from our system in a much more kind of reliable way. But there was still a long road ahead of us. Those pipelines were running though very slowly. They were sequential, and there's a lot of kind of time that one needs to run one entire pipeline like that. So after a little bit of analysis, it was clear the problem was the data. There was too many data into these production pipelines. So the approach we decided for as a solution for this problem is to sample the data down. So we reduce the data for the CI, and so we can have the entire pipeline running much faster. Yeah, we also saw this is a need of any project, and there's probably a space here for a tool. We look also into the ecosystem. Our stack is Python plus Spark, and we couldn't find any tool that would solve this problem for this particular ecosystem, so we decided to build one ourselves. And now one of the key design decisions I want to explore a little bit is like if you sample in a centralized fashion or a decentralized fashion. Centralized means you create a parallel data warehouse with like all the data items, but much smaller, just a sample of them. And then when in your pipeline, you just change your database source to be this kind of, to point to this sample data warehouse. That's one approach. The other approach is decentralization, which means we move the sampling to each ML pipeline. So they own the sampling there. with the centralized approach, it's very easy to get started. That's a big plus. So you just need to change a single parameter, the data warehouse name. On the other hand, there is a lot of more kind of lower end of the funnel costs. You create a centralized infrastructure, maintaining it becomes expensive. And over time, definitely will happen that this data will drift away from its original production data. So how to maintain these things can become very tricky. On the decentralized end, you have complete control over the sampling strategy. You always have access to real data. The downside is that you need to much more effort in the initial setup, right? You need to set up sampling for each project. In the end, we landed with the decentralized option, as it's basically scales better. It's more self-service, and that's a good attribute for platform work like this that we believe on in Get Your Guide. So with that in mind, now this is an overview of how the DDataflow looks like. It has basically sampling functions that are applied conditionally into the pipeline if you are in production or in the CI. That's a very high-level view. Theo now will basically go deeper and show how this looks in practice.
Mm-hmm.
Should I?
Yes, yes. Sure. What I propose is that I will do just the slides. We go until the conclusion, and I will do the demo afterwards.
Okay,
so then we.
Yeah. Okay.
You continue.
Okay, sounds good.
Mm-hmm.
So.
Yeah. So here I will show you a bit more how we declare the data sources, so that we'll be able. So we have DDataflow, and then you will need to have a config where you declare the sources, your data sources, where you say how you will need to read the data that you need, and afterwards how you can filter which is only used when you want to sample the data. And so for each of your data sources, you can define a different filter, because not all of them have the same, might need the same logic for filtering. And once your config is there, then you can initialize the DDataflow object. Okay, now let's see the different modes. The first one is when we have DDataflow enabled, which means that we have the data sources, but we want to sample them. So first I will go through the filter, then where they will be sampled, and finally then it can be piped through to your ML pipeline. But then you just have the sample data, which will run faster, and then you can run it on your CI. The second mode is when you have DDataflow disabled. Here at this point, we want to run in production, so we want to get the data sources and directly have the full data set pushed to the ML pipeline to have the model that we want to use in production. And finally, the last one is when we want to use local development. Here we also want to develop to get the data sources sample, but then what we want is to be able to download this small sample data on your local machine to be able to iterate faster with this sample but realistic data. Okay, we also have a demo we will try to do at the end, but first let's go through the conclusion, and then I will do the demo.
Mm-hmm. Right. So as now we having this tool in place, we really enabled our teams to have like end-to-end tests with real data in the CI. This to give some data points there is like how much a pipeline will take in the CI before and after the data flow. So it can really speed up a lot, and it makes the feedback loop much faster than before to understand if your code is working, detects much earlier problems, and allow new use cases actually to enter the CI that before would even be considered as possible. And in conclusion, like DDataflow now is integral part of majority of our ML pipelines in production. It had a transformative impact into our pipeline efficiency. it also delivers value at scale with small tools. This is a very good practice within our organization, that we believe in small tools, adding value, and being self-service, rather than trying to build like an end-to-end ML platform. We find that ML productivity is much better served with small, very targeted tools that are self-service as well. Yeah, and we are looking for the feedback from the community. The tool is open source, so you can try it out. And now let's go to the demo.
Okay. So can you stop sharing? I will start sharing again. Okay. Click. 1 second. Share screen. And I want to share this screen 3. No, still not. I can. Just a second. Let me try something else. Window. I will share my. I still have some problem. I don't know why.
The demo got punishing us.
Okay, let me try to share this. Okay, great. I cannot share the full screen, but I can share that. So first I can install DDataflow. I can share this. You all see it. It's first. So, and then we can define the data sources. And here in the data sources, what I'm doing is taking the departures of the flight delay, which is a kind of open source data set around flight delays in the world, and it composed on 2 things: one about the delays itself, another one about the call airport. And for each of them, you can define the sources, how you want to how you can read it, and also the filter afterwards. And finally, I can then create the DDataflow object. And first, as we said before, we can have DDataflow enabled, which means that we will be sampling it. And then you can call the sources by calling through the name that you defined earlier here. And here we can display, and we see we have the sources that have been sampled. The first one just start with the letter B. That's our sample saturation that we have. And the second one, we just say that we want the top 100 rows. Then if we want to disable, now the CI worked. So let's imagine we want to go to production. We can then disable the DDataflow. And what we see here is that we have then all the letters in the origin here. And the second table have more than 500 rows. Okay. And finally, when we want to DDataflow sample the data, basically what we have to do is first to save the sample data into a folder in dbfs. And once this is done, we see we have it enabled here. And I will need to then show how I can run it locally. And for that, I will need to stop sharing and try to share another one. That's what I wanted to avoid. So I want to share my, why is it not Visual Studio share? Great. Okay, I cannot share my PyCharm. I try a second time, but otherwise.
I think we nevertheless got to the book of the message with the notebook experience.
Yeah. And then you can basically run the same code that you have and have also the thing downloaded on your machine that will be able to get the data by itself. Okay, sorry for this last technical thing. We didn't expect this problem. Great, that's it.
Yes, I will leave open here just a link with DDataflow. It's on GitHub. So, and we are back. We are open to questions.
Looks like we have one currently in the Q&A section. So if we navigate there, Again, anyone who is listening or anyone who is looking to get any answers to your questions, please drop those in the Q&A. We can kind of go through those right now.
Should I read it out loud? Does DDataflow only work with Spark? Can you elaborate more what integration DDataflow has? Yeah, I can get this one. It only works for Spark at the moment. I mean, nothing prevents you have other kind of distributed data processing pipelines in place, but would require a project to make that work out. But yeah, I guess that would be possible as an open source project to add such support. Yeah. How does DDataflow generate test data? Is it synthetic or filtered subset of production data? You want to get that too?
Yeah, no, it's a filtered subset of production data. So that's was the main problem that we have. Creating synthetic data was very cumbersome, and what we saw is by using a filtered subset of production data, we could test a lot of things, and that's why we created this tool to be able to wrap this logic of how, if you want to filter it, if you want to get this, how you want to sample it, etc.
How fine-grained are filters for sample STO guarantee dependency in the data? I think I got the gist of it. Can we trust the filters in our pipelines, right? I guess it's an excellent question, and I think that's the best we can do, right? You get the expert to write the filter itself rather than trying any other way to kind of filter the data. So this brings the filtering problem to the data scientist who owns the pipeline, and then we can basically figure out the best method for each specific situation. There are some sort of generic recommendations that we can give, but in the end, there's a lot that goes to use case specific needs.
Yeah. Okay, could you share the DDataflow repo URL on the slides? So we'll share the slides. I'm not sure exactly, but how, but I'm pretty sure we will be asked to share the slide. And the URL of the repo, you can already get there by the small QR code, or you can also look for DDataflow on PyPI. Perfect, even better.